Okay. All right, that's cool. So that's another example. Okay, are there any questions about that? So there is something else I want to do from this section. The next section will, I don't know if we'll start it today, but although we might, because the next section is synthetic division. I figured it would be good to try that. And after that, we do trig. Fun stuff. Okay. Oh, yeah, this is again what I was trying to say. Even graphing it by looking at the observations, we can see that there are no x-intercepts. Okay. Okay, so remember how this was the standard form of a quadratic function. You can get from this form to the form we're dealing with, that ax squared plus bx stuff, because you could just FOIL this. But to get from that form into this form, you would have to do completing the square. And I figured with our time, our time is limited in this class. I figured it'd be better to just skip over completing the square. It's actually very interesting in that it's where the quadratic formula comes from. But anyway, what's nice about this form, though, is you can easily get the vertex. It's just hk. What's nice about this also is if you wanted to come up with a formula for a quadratic function, this might be easier to work with, as in these examples. But even if I give you a graph, then you could still get a formula for the quadratic function using this. I mean, if we know the vertex of the quadratic function, of the graph, and we know a point it passes through, we can come up with a formula. For instance, let's find a quadratic function whose vertex is 2, 0, and it passes through the point 1, 3. The graph passes through, that is. So if the vertex is 2, 0, right, what does that mean? That means the point hk and 2, 0 are the same. And when 2 points are the same, their coordinates have to be the same. So the x coordinates are the same, and their y coordinates are the same. So 2 has to equal to h equals 2, I mean, and k has to be 0. I probably should have put this on the left side, but I guess it's okay for now. But we know what h is, we know what k is. Let's plug it in. Get this. And you should be able to see that, well, we're not done. What's a? Right? What's a? But we have another point that it passes through. Now, if you're given something, you really should use it. Odds are, you're really going to need it if you're given something. And we know it passes, we're given it passes through the point 1, 3. So in terms of our function notation, this is saying that f of 1 has to be 3. F of the x coordinate is the y coordinate. So f of 1 has to be 3. Let's see if that helps us with a. So I plug in 1 for x. We know f of that has to be 3, as you can see. You get this? Okay, well, does that help us? Well, what's the right-hand side equal to? 1 minus 2 is minus 1. So we have a times minus 1 squared. Minus 1 squared is 1, so we just get a. So a is 3. And our quadratic function looks like this. We get that. Okay, hopefully that wasn't too bad. I mean, I didn't try to answer the question here using the other form, the ax squared plus bx plus c. I'm not saying it can't be done. I just think it'd be a lot harder, a lot more involved, I think. But what's nice is we don't have to. We have this form. Well, that was so much fun. Let's do another one. So now let's do the same thing. Let's find a quadratic function that passes through this vertex, that has this vertex, excuse me, and it passes through this point. Well, it's really the same idea. In that, we know the vertex is 2, 4, so HK has to be 2, 4. So H has to be 2, K has to be 4. Plug it in. As you can see, it's always x minus h squared. I mean, if you have your h's negative, then you do addition, as we'll see. Now, are we done yet? No, we have to figure out what a is. But we know that this passes the point 4, 7. So 4, 7's on the graph. 4, 7, that point has to be a solution of this equation. Let me say it better. F of 4 has to be 7. If I replace x by 4, I have to get 7. In other words, if I replace x by 4, we have a times 4 minus 2 squared plus 4 has to equal 7. And then I just wrote this out. What's 4 minus 2? Well, that's 2 squared, right? So we have 4 times a plus 4 on the right side. That's all equal to 7. So we have this equation to solve for. A is basically our unknown, and that's what I'm solving for here. I like to put the unknowns on the left side. I mean, it's actually what we're supposed to do. So that's why I put it over here. And we're just solving for A. A is the unknown that we're looking for. And if you go through the calculations, which I have here, as you can see, we get A has to be 3 over 4. I mean, I guess you could always graph it in Desmos or GeoGebra as a check. But that's what we get here. All right. I mean, there were some examples I want to do with you guys, but we have a minute left, and I don't want to rush through it. So I guess, unfortunately, I think we'll have to stop here. I don't want to rush through an example because that's not going to help any of us.